Hello everybody and welcome back to the free online woodworking school where we aim to take your woodworking skills to the next level. In the next couple of videos, we're going to be turning this beautiful bit of curly walnut and this rather mediocre bit of ash into a frame and panel door. Let's get going. Now, when we teach this project at Rycotewood, instead of using a solid piece of timber that we're going to be using in this video, we use a veneered panel instead with some sort of marquetry or parquetry design on it. In this case, we're not going to do that because it's a big old topic in itself and a lot of you won't have access to veneering equipment. So instead, we're going to continue the traditional arts and crafts style look of this cabinet and goes for a raised frame and panel door instead. Now, I'm going to level with you here. I have never actually made a raised frame and panel door before, whether it's by machines, hand tools, power tools, anything in between. Never actually made one because it's not really to my design taste, and the furniture I've made in the past, I just prefer the look of a flat panel with a nice piece of wood in it. I was tempted to do it for this, but I knew a lot of you would prefer the look of a frame and panel door, so I thought I would document how I would go about doing it, even though it's my first time, and then hopefully you can learn from my successes or potential failures. I think I've got an idea of how I'm going to do it, but we'll see. Now, because this part of the project is going to be broken down into very small bite-sized chunks, in this video we're just going to be focusing on sizing and grooving the frame of the door, and I'm going to show you both the hand tool and the power tool method of doing that. Now, this piece of ash is quite long at the moment. Ideally, I want to cut this down into more manageable chunks because that will be far easier to groove by hand and also by machine. If you were doing a ton of these frame and panel doors and you needed to get a lot of these components out, by all means you could probably just run these all through a spindle molder or a router table, whatever you have set up in order to do the grooving. But seeing as this is a one-off and I want to make this as easy as possible on myself, I'm going to cut this down first. And so I'm going to cut two sections that are to the length of one short side and one long side, and then obviously one long side, one short side, one long side. Cutting it in half will also reduce this slight bow you might be able to see along the length of this component, because if this stays in one long length while I'm grooving it by hand on in particular machines, then that bow may cause some issues. So now these are going to be so much easier to manage when I'm machining it or doing it by hand, whatever. And I'm already taking into account at this stage the grain direction on the stiles and what may be the rails as well. By the way, bit of terminology for you there. The stiles are the uprights on the door, the rails are the horizontals. Easy way to remember it, horizontal rail is what you tend to grab in life. So yeah, horizontals are the rails, uprights are the stiles. And I'm looking at this and I'm quite liking this sort of grain. It looks like a book match, it's not, but I'd quite like this grain to be either side of the door, meaning that when these bits are cut off, they would then become the two rails at the top and bottom. So I'll put them together like that, and then we'll do a face side and a face edge on what will be the outsides and the front of the door. And I'm going to do it up here as well, because obviously this will be separated. And so that means the groove is going on these inside faces, and I scribble it on roughly with a pencil, so when it's on the machine I can easily see which side I'm meant to be grooving, and I'm not going to accidentally do the outsides, which is quite easy to do. Now let's start with the hand tool method first, and in this instance we're going to be using this, which is a plough plane. This is for cutting grooves, and you can put different width blades in this depending on what thickness panel you want to insert in the groove. They range from about 3mm up to about 12, maybe even further with this plough plane. If you're interested in this, I'll put a link to it in the description. And of course, it'll also be available in the tool list available for this project on the project homepage. There'll be a link to that in the description as well. So the groove I'm going to be putting in this is going to be 6mm wide by about 6mm deep, maybe 5mm, something like that, but definitely 6mm width, and that is going to be dictated by the width of the blade that I've already put in here. 6mm wide or 1/4 of an inch, which will give you 6.35mm. Doesn't really matter too much because we've got a solid wood panel that we can thickness to fit the groove afterwards anyway. So we've got a 15mm component, which means we need to come in 4.5mm from either side, which will give us 6mm in the middle, which will be removed with the plough plane. So I'll set the marking gauge to 4.5, and then we've got the face side mark here, so we're going to reference the marking gauge against that face, which is going to be the front of the cabinet, and then we'll scribe that all the way along. So I'm just using light pressure for now, and then we'll do a slightly deeper one just so we get a really nice mark from that. Now I could mark it again this side, going in 4.5mm, but there's no point in scratching two lines in here. What I'll do is just line the corner of the blade up with that front line we've got there, and then the back end of the blade will do the rest. And so in this instance, the fence of the plough plane isn't allowing me to bed the plane down into the material, so I'm going to have to remove that and just run off the metal fence instead. And then once I've got this removed, I will jimmy it round a little bit until the front corner of that blade lines up with the line that I've just scratched on with the marking gauge. And then next we'll set that depth stop to about 5mm. Right, and then we'll get grooving it. So much like the rebate plane in the box project, we don't want to start all the way back here and go for that groove in one hit, because it gives us all this room to start tracking the grain. Whereas if we start here and do a short stroke and then a slightly longer one and then a slightly longer one, and we gradually increase it, it's going to be creating a track ahead of the cut that it will fall into. So effectively, the only bit of fresh cutting it's doing is about an inch long, and then after that it falls into a track created by the cuts made prior. Cool, so now we're working on those long strokes, and just remember to keep it nice and straight in there. Make sure that fence is properly pushed into the material and not tipping whatsoever, because you don't be wanting an angle groove at this point. The way I do this is get the plane locked in and then do the action purely with my legs. So that rocking back and forth, and there is no movement in the arms whatsoever. So get it in square, carry it through with your legs. So as you may be able to see, it's a tiny bit off center. This front is a little bit thinner than what's at the back, but as long as you're referencing from that face side on all the components when you groove them by hand or by machine for that matter, that small error will be cancelled out across all the components and the offset will be absolutely fine, providing you always reference off that face side. If you don't, then your grooves are not going to line up and you're going to face some problems. And so that's the hand tool method complete. It is quite literally as simple as that. If you've done the box project prior to this, which you probably should have done if you're tackling this, then that process will be very familiar to you. It is much the same as using a rebate plane. Just make sure you start off with those short strokes, make sure it stays nice and square, and make sure you bottom it out using the depth stop, or you at least measure the depth of the groove or the rebate to ensure it's consistent across its length, and everything should be lovely. So now, power tool method. Now the power tool method of cutting these grooves involves the use of a router table. I'd strongly advise doing this on the router table rather than with a handheld overhead router. By using a router table as opposed to an overhead handheld router, you'll get far more accuracy, you'll probably get a cleaner finish, and above all, it'll be safer. And so for this, we're going to be using a slotting cutter, which will cut into the side of the material as opposed to coming up from underneath the material and cutting like that. This means that it's effectively cutting like a circular saw blade as you push the material into it, and you're pushing against the resistance of the cut, therefore giving you more control. Now these heads are interchangeable. You can get different thicknesses to suit different grooves. Just make sure that when you replace it, you put it on the right way up. It's possible to install these upside down, and therefore that tooth is unable to do any cutting. Instead, you'll just get a ton of resistance and burning, and it'll be pretty obvious if you get it the wrong way round. So I've got a 6mm cutter in this to match the thickness of the panel I want to put in there. And I've got insert plates in this particular router table. I want to talk about these just quickly. Now, when I put insert plates in, I use a size that allows the cutter to retract fully into it. With slotting cutters and many other router cutters where they overhang the shank, it's possible to obviously put in inserts like this, where it will still grip the shank, but the cutter will protrude above it. This will obviously give you more support, but in the very unlikely event of something going wrong while this is spinning, or in fact while it's stationary and I accidentally retract the router, therefore dropping this into that insert plate, you know, who knows? If it was on, then that would be very troublesome. If it was off, then dropping it like that may end up changing the protrusion from the collet underneath, thus making it inaccurate or, God forbid, lose its grip. So although it's not nice seeing that big gaping hole surrounding this, I tend to roll with it in these instances just to be safe. So we'll insert it up to the lines that are printed on the shaft. So again, in this instance, it doesn't really matter if you run it through with the face side up or down, as long as you're cutting it on the side that you've marked the groove, and If you choose to do it down, make sure you do it with the face side down on all the components, or vice versa, make sure you do it with the face side up on all the components. Now in this case, I'm going to do it with the face side down, because when we were using the plough plane, we used the fence of the plough plane to reference against the face side. And in this instance, we're going to be using the router table itself to reference against the face side. And so for demonstration purposes, I think it makes it clearer, and like this is the way I would do it anyway. And so I'm going to adjust this until the bottom of that cutter is 4.5 millimeters up from the table below. So that's our up and down movement sorted, and now we need to sort out the side to side movement. And you've got a couple of ways of doing this. You could either replace the bearing on the router bit itself, and if you get a large enough one, that will restrict the cutting depth to 5 millimeters. But in this instance, I don't actually have one that large. And so we're going to be using the fence itself to sort out our side to side movement. And so this is pretty simple. All you've got to do is make sure that cutter is protruding 5 millimeters out from the front of the fence, and then when that passes through, it will take a 5 millimeter cut. The potential problem with this is, with that large open cavity to account for this spinning cutter, when it takes the cut, you can sometimes get the material stuck in here, particularly if you've got feather boards pushing on the front, which we will do. They may force it into that cavity and it will start cutting really deep, and you know, it might end up catching the router cutter. A few things could go wrong here, and that's in the instance of a router table. If you're doing this with a spindle molder where that cutter is about 5 times the size, therefore these gaps are 5 times the size, yeah, you're going to run in with some real issues there. So you want to make sure this area is shrouded. And so this is where a false fence is going to be used. And I use this pretty much every single time I use a slotting cutter on a router table or a spindle molder or any other operation where I'm worried about that large open cavity. And so to set this up, we'll slightly widen the cavity to give ourselves a little bit of room around that cutter, because this operation is pretty much blind, as you'll see in a minute. And you need to make sure that if you accidentally skew the fence, it's not going to start hitting the cutter. In most cases, it's not an issue if it does, because you know, this is made of MDF. Sometimes the fence is made of aluminium, so it shouldn't do too much damage, but ideally you don't want it to hit the fence. And so widening that about 10 millimeters either side of the cutter should mean that I'm not going to accidentally hit that if this fence is unintentionally skewed. And then with that fence pulled forward so it's ahead of the cutter, we're now going to clamp this false fence in front of it. So you can see this is the blind aspect of it. So when you clamp that in place, you need to be absolutely certain that it's not touching the cutter. This is about 6 millimeters thick, so I can just bend it away a tiny bit to see if it's clear of the cutter, which it is. And obviously I already checked the sideways movement of the adjustable fence to ensure it's not touching anything there. And what we're going to do with this is turn the router table on, and as it's spinning, we're going to push this fence back through the cutter. And as the cutter cuts through here, it'll eventually get to a point where it's protruding 5 millimeters, and we'll be able to take that pass safely without risk of the component dipping into the cavity. And because there's quite a large cutter behind there, I've turned the speed down to just under halfway. So let's fire it up and start pushing the fence back through it. And then double check that it is off, yes. And then we'll just spin this round so we can see that cutter exposed, and then measure where that is. So that's sitting at about 4 millimeters at the moment. We need to push it back a little bit further. What I tend to do in these instances is push the fence quite far back, so then this is protruding a lot, therefore giving it a nice wide space to get up to speed, and then we can fine adjust it after that. So let me just push this back a little bit further. And there you go. So now it's got a nice wide slot to get up to speed. So I can bring it out like that, and just bring that fence forward until it hits 5 millimeters. And of course, we'll do a test cut to ensure this is fine. But now that that slot's nice and wide, I can be pretty certain that when I lock this off, it's going to have loads of room to get up to speed, and it shouldn't interfere with the fence. Lovely. So next we'll get some feather boards into position, and these will help keep that component pushed securely into the fence. Just keep pushing that forward until we get a nice firm bite on that component. Let's go a little bit harder than that. I do like to make this quite secure. Yeah, that's pretty good. And so ideally you would have another featherboard up above here, holding the material down into the bed. But unfortunately, for starters, I've blocked off the T-track, but I've also lost the T-nuts that go into that T-track, therefore allowing me to actually fit the featherboard to it. So we wouldn't have had it in this instance anyway. So instead, I'm just going to use a push stick. And as it's going through, I'm going to be putting pressure down from above, quite firm pressure as well, making sure that this component stays firmly in the bed. And this is, of course, a test piece. In fact, it's the piece that I just demonstrated the hand tool method of doing this. And so obviously it's the exact same dimensions of the material I intend to put through it in a second. 15mm thick, 30mm wide. Let's see how it ends up. So let's see, spot on in the center. That is, you know, I can't do any better than that really. And let's just check it is actually 5mm deep. 6mm, that'll do, that's fine. So that was lovely and accurate. The only thing is you probably noticed it was quite choppy as I was pushing it through. It like sort of jumped a bit. That's because I've set the featherboard to be pretty tight, pushing it into the fence, and this fence itself is quite grippy because it's a rather low quality plywood. So I'm just going to wax everything to make sure it's nice and slick for when we do the real thing. This is a machine wax I'm using, so won't affect any of the finishes that are applied at the end of the project, and you know, it'll be sanded anyway. And if you don't have a proper machine wax for this, candle wax will also work rather nicely. Right, so we'll just remember face sides down and groove is obviously up against the fence, and we'll do that on both components and we should end up with some lovely grooves. And there you go, two very different ways of creating grooves on a long component like that. One by hand using a plough plane. Again, there's links to this in the description if you're interested in it. Alternatively, the other method is the router table. Just make sure that you use a false fence with it to ensure that the component doesn't get sucked into the cavity where the cutter is spinning and thus turn it into a big wooden stew in there. Routing is an entire series that I'm still planning. I've been planning it for about half a year by this point, and it will be something that's released after this series is finished. We'll go over overhead routing, table routing, and all the other various forms that are available in that ever expansive topic. So as always guys, thank you very much for watching. If you enjoyed the video, please do not forget to press the like button, subscribe if you haven't already, and you can move on to the next lesson by clicking the link below. I'll see you there.